Shahab.
Hi, Buncha.
Morning.
Hi, Shahab.
Hey, Anu.
How are you?
Oh, now it's better. Good.
I'm here for actually two reasons, because I was in another meeting. I just dropped off to come so I could get a chance to talk to you, Shahab.
Sure.
There's a couple of things that are due today. The board-out optical portion of
Oh,
the
you're
the
right.
bow talk. It was
Okay.
actually due yesterday, sorry, 26th.
Oh,
Yeah,
okay.
so I know. But so the way we did it is Ilad is the guy who collates everything. So Ilad has a preliminary talk, and then there's you, Cash, and Kevin with each of the three pieces. I think everybody else has put their stuff together, and I think Ilad has submitted because 26th, it was
What's the draft, basically?
it's a preliminary slide deck deadline, and these are all, I understand, artificial deadlines. So at least we've got something in there. But if you could make your slides,
Sure.
the format has to be it's downloadable from the OCP site.
Then I have to do it for PHY, die to die PHY as well.
Yes.
That's that totally I forgot that. Okay.
Yeah. So those two are due. If you could, just put in something, Shahab, so
Sure.
Kate doesn't harass us.
Okay.
So you have existing slides, just put it into the template format, and then as you finalize your talk, you can make, I'm pretty sure we can make revisions, because look, everybody has 3 million
Even
other
I
things
do
to do.
have it in the slide format, and just need to figure out where I need to submit it, but everything is ready.
Oh, perfect. It's the FN portal.
Okay, I will do that.
Yeah, I think I'm pretty sure from last year you already have an account and everything set up. So it's
Yeah.
actually relatively very simple, because I made a submission last night. It's not too hard. The other thing for you, so Shahab, there's two you are on the clock for: the Board Optical and the D2D metrics talk for the Global Summit. And then for tomorrow, between you and the test guys, 15 minutes have to be shared. So it's really about 6-7 minutes.
5-6 slide. I'm gonna just highlight why do we need this.
Yeah, perfect. I just
And
wanted to make
tomorrow
sure
at
that
8
we were
a.m.
ready.
Hi, guys.
Sorry, it's on Wednesday, 8.
Yeah. Hi, Majid.
How are you doing?
Hey, Majid.
Good. Long time no see, no speak. It was nice to see you on the call on Friday.
Okay. Yeah. Busy. So
Yeah, I know.
Sorry,
So
the
Shahab, that is
presentation on
28.
Friday or tomorrow at 8 a.m., correct?
Yeah, I sent you I forwarded you John's Zoom link.
Okay, I will look at it. Thanks.
Okay, perfect. And Shahab, any questions, just reach out to me.
I will do that for sure.
Okay, thank you so much. I'm going to drop off because
what was the portal, FTM portal, something?
No, hold on. FN portal. Let me I'm actually logged into it right now, so I'll send you a link to it. Speaker. Yeah, I'll just cut and paste it here
Thank you.
in the chat window. Paste.
Got
Yeah.
it. Thank you.
Yeah. And you should have account and everything. You shouldn't have you already have a profile set up. So
yeah.
Okay, got it. I'm gonna hang up now to go back to my other meeting. But thanks, Shahab. Appreciate it. And sorry, there's so many deadlines, but
No, that's okay.
can't be
Sorry.
helped. So
Yeah, thanks.
thank you.
Thanks,
Bye.
Bob.
Talk to you later. Bye.
Thank you. Okay, hi everyone. Hi, Majid.
hi. So I just did a bit of modification to the white paper.
Oh, you did? Okay, do you want to
Yeah, so
share?
that's
And
why I thought, I come by and explain what I have there. It's all as a suggestion, so you could
okay,
accept it.
then do you want to share your screen and then we can move forward?
Let me see. I thought that you were gonna open it. Let me see. 1 second. Okay, so right. So I think the executive summary still needs work. I
Okay.
guess there was some text that I think we need to write it up so that effectively just you could copy the goals that you have. It's a good way. But one thing I wanted to mention, it's not just die to die, obviously, right? It's
Okay.
all electrical interfaces, right?
Mhm.
But I didn't enter anything there. I just went through some of the things that we already had here. Let me see the first change I made. Yeah, I just add here linking it and can be considered as generalized differential signaling, multi-wire panel signaling. Okay, is no single important change. That's easy. Here, okay, I change everywhere that you have PAM X to PAM N, maybe, because it's a number, right? Usually PAM 4. And you could even use PAM dash, but I guess everywhere you have PAM 4, PAM 2, so I just added PAM N instead of PAM X.
Makes
PAM N.
sense. That's great. Thank you.
Okay. Then here, it's the biggest change, I guess, what I here what I had, let me see those. Okay, so so here you had PAM N, and then PAM signaling can be combined with multi-wire signaling to enhance link performance. And then what I added here, I have a hard time moving things around in this window, but let me see. Okay, so I added this paragraph, and I think there's a confusion there. It used to be multi-wire PAM, and it was really referring to having multiple lanes. And since you explain multi-lane later in section 2.1, I suggested to remove this paragraph altogether, like DSL and other things. Correct me if I'm misreading this. Basically, like in Ethernet, you have 4 lanes, differential pair of PAM4 or PAM, NRZ. And this is what's kind of referred here. What I wrote instead for multi-wire PAM-N can be done over single wire, 2-wire, or more than 2-wire. Okay. PAM-N. And example of single wire PAM2 is single-ended signaling in bunch wire 2.0 die-to-die specification. Example of 2-wire PAM4 is PCIe 64 gigatransfer per second in PCIe SIG specification. And core signaling ENRZ is an example of PAM2 over 4-wire in YFCI 5 specification. So I made it brief, so you guys, there's too much about chords, so I just here clarified. Does it make sense? First this addition, and then the second is the deletion.
Yeah, I'm reading. We had multi-lane and we had multi-wire.
Yeah, because it used to be multi-lane. I changed the title of it to multi-lane. If we had to explain here, but then I realized it doesn't really belong here, because here you're just going through, the title is signaling types, NRZ PAM2, PAM4 or PAM-N, and multi-wire PAM-N. So that's why you already had an explanation for an RZ PAM-N, and I just added multi-wire PAM-N, which used to be here. It used to be, I mean, I changed it here. I started changing it and I realized actually it's not the right thing. And if you go to section 2.1, that's the first time properly defining multi-lane, right? Here, number of lanes, right?
Yeah, makes sense. I think
Yeah.
it's
And I think it also, for example, you could also talk about other places if you want to, here, we only talk about die to die, but it could also be about, PCIe has by 4, by 8, by 16, and Ethernet has by 4, etc. But four of them, actually, no, 4 lanes. So that's an example. By example always is nice too. But I think that's not the purpose. That I just wanted to clarify this edits here. So hopefully makes sense. So that's it. I mean, we haven't done anything more than that. And I think you guys had done, description of code limited. It's okay, no problem. And that's it. I think there was some edits that I think Kevin suggested here. I don't know if you had a I don't know if you went over it.
Yeah, we did. There was a confusion between source synchronous forward and forward clocking. I think he fixed it.
Okay, so it's fixed up. Okay, so these you could accept, I guess, removing because I didn't suggest those edits. And so one of the things that we have to just generally, we kind of go between a lot of focus on the die to die and also talking about other interfaces, other electrical interfaces. Maybe we could make sure that it's consistent, right? So for example, if we wanted to talk about this, I mean, in PCIe or in Ethernet, it's not really this kind of topology, but or USB, for example, the way the USB type 3 is defined, you could see that they put it in pairs and they kind of put a so if we wanted to make it more not balanced, more consistent with addressing all kinds of interfaces, it may be interesting to add USB type 3 is a very
Yeah, but what do you mean by confusion? Can you elaborate more?
No, I don't mean, I mean, is this about die to die only, or is it about general?
Doesn't matter. This is a bomb path, and we are saying
No, not the bomb pap. I'm talking about the paper.
no. I mean, you're referring to the section of the bomb, and you said it's confusing. Yeah.
No, I didn't say it's confusing. I'm saying this is an example. We're focusing on die to die, and there is no equivalent for other kind of
If
topologies.
99% of our focus is on the die to die, but if someone else wants to use it and they have a predefined bump map, they can say it, or they can say, hey, we don't have a bump map. But remember, this is an implementation. If you implement something, for sure there is a bump map.
Right, for die to die. But I'm talking, for example, if you look at a USB,
Even
right?
for USB, you do have a bump at the end.
Yes. But the way they the distances and the separation of lanes to avoid crosstalk, etc. It's all based on similar kind. It's just a physical channel, effectively, the bump of the channel, right? So, but I think that becomes too ambitious if you want to go over it. But I just wanted to make sure that it does look like that is for other kind of interfaces as well. And okay, this last sentence I added. So I wanted to say, because the title here, you're talking about all these categories, FEC, CRC, retry. I added, you already had written overhead, but I added one sentence before we go through it. One also needs to consider the added latency, complexity, power, and overhead cost of CRC, FEC.
And which one is your, oh, okay, that one's the one also needs to consider added latency, the cost of the series.
Or error, any kind of error handling, what is usually that's, but you already explained it, and I just wanted to, in the intro, talk about it.
One of the point, Majid, we wanted to not make a judgmental call.
Yeah, but that's not judgmental. Every FEC, every CRC, and every retry has latency. It just inevitably has
There is a
latency.
reason behind it that people burn that much of power rather than burning power on making, for example, signal swing larger.
Right.
It's a matter of increasing of SNR. Either you can burn your power on
Sure,
signal
but
level, or you can actually do the coding to get the better SNR. I mean,
yes, but for example, in
added latency, complexity, power, for me, it sounds like that you're saying, hey, CRC, FIC, and retry are not good.
No, I'm saying okay, so for example, Ethernet, 224 or 400 that they're considering these days. You make all these trade-offs between reach, speed, and power and latency. And one of the things that you deal with is error handling, and it's not a judgmental call. Error handling is a tool, and is one of your dimensions. So, for example, in PCIe, they added retry, strong FEC, strong CRC, and light FEC in PCIe Gen 6, and that allows them to have post FEC 10 to the less than -22, that kind of thing, while they assume -6 BER, right? So it's not a judgment at all. It's basically error handling comes with added latency, complexity, power.
Latency, I understand, but complexity is a negative word.
Yeah, but you add a logic. The logic of FEC is extra power, extra complexity of the system.
Yeah, but complexity, anything that you add is complex.
Sure.
Can you suggest one change that is not complex?
Okay, I can remove, because for me, complexity and power are the metrics that people care about. So I can remove complexity, but power, for example, when you do power, if you look at what we suggested in UCIe recently, we did a study, Candu did it and presented a study where we say, here's a way when you go to 64 gigatransfer per second, gigabit per second per wire, you could avoid increasing your bit error rate by having a FEC. And one of the reasons that people are not open to it, that they say, okay, there's it adds extra power and it has overhead and it has latency. So you trade off those things by adding it. And how you choose the scheme depends on these considerations. So for me, really, you have a spider of these metrics, okay? And you could choose the dimensions of this spider of figure of merit.
I totally get your point, Majid. And also we do have the latency somewhere in the text if you scroll down.
Sure. No, I saw it. But I wanted to say associated with error handling in particular.
If you go down slightly, just maybe.
Yeah, you're explaining it. Latency refers to blah blah blah. I see that.
No, not that one.
Mm-hmm.
We have a sentence start with while FEC enhance the reliability. I think it's a little bit maybe higher. You pass.
Yeah, latency. And by the way, this is strange that it carries.
Can you scroll down slightly? Then I can show you the text a little bit down. Next page. Next page. Down. You're going up.
Down. Yeah. Okay.
Yeah.
No, here. Yeah, I read this part.
Here, right here.
Yeah.
While FEC enhance the reliability of communication by reducing the probability of data error, it does introduce some level of latency, both on transmit side and calculation the redundant information on the receive side.
Sure. And CRC the same, okay? And retry the same, okay? All of these toolbox of error handling.
Correct, but retry doesn't add latency.
Absolutely, it adds. Every time in PCIe that you have retry, the probability of retry, okay, when you are accessing memory, transactions of memory, you could pay a big price if you have too many retries. So retry is it takes about 200 nanosecond a retry. So depending on probability of retry, so that's why
I understand that part, but if the probability of retry is 0, then there's 0 latency.
But well, you don't then need to retry.
Then
but
the
you see,
mechanism is there, but you're not triggering it. That's why you
no, in PCIe you do. The philosophy of error handling in PCIe is expressed like this. They say, we gonna make the probability of first bit error so low, -6, 1 - 6, so that probability of retry and other schemes, so that the probability of retry go down, so that once retry happens, the latency penalty of it is acceptable.
Okay,
and then
I totally understand what you're saying, but I'm gonna challenge you on one thing. Can you define latency with respect to the retry?
Yes, so there is a handshake. So if I show you PCIe scheme,
measure it and report it.
Yes, there is a paper. Let me just actually bring you a paper that this is studied in depth. The PCIe. Let me see. PCIe standard. I mean, this paper is a public, so I can even share it. I don't know if I'm sharing my screen. I hope I'm not. It's still the paper, right?
Yeah, we are still looking at it.
Okay, so I'm good. Let me see, because some of these things are okay. So if I go,
Imagine it's okay. We have only 5 minutes to
Okay.
wrap up.
So here,
My point was, it is impossible to measure latency because you don't know what's the targeted bit error rate.
no, there is a graph. That's what I was going to show you. There's a
But you don't
paper.
know the application of the people. You don't know if 1 e to the power of -6 is good for me, or 1 e to the power of -12 is good.
No, but and I'm not at all saying any of that. What I'm saying is error handling, be it CRC, be it FEC, be it retry, all of them, there are trade-offs. And
I
this is
100% agree with you. But if you go back to your sentence, but that's again, that's only one view that I have. My whole basically goal for this paper is, one of the main objective is to not imply one technique is good or bad.
But we're not saying that, which everything comes at a cost, right?
That's everybody knows about it, but I got the feeling that sentence is actually telling people that, hey, the CRC, if you have an option to not use CRC and FEC or retry, it's better to use that.
No, it doesn't say. For different application and different channel conditions,
Can you go back
different.
to your sentence, please, for one minute?
Yeah.
For someone who is reporting some information, I don't see that line.
No, I mean, if you, I mean, I have no objection removing it, but
No, we will
to
keep it.
to me, that's a fact. That's a fact.
Of course, it is fact, but you're telling them one also needs to consider why, when the people are reading this paper, why they need to consider.
They should say what is what kind of you have that graph that says let's deal with I actually made some suggestion to your presentation, minor suggestion. One of them, you have this graph that says we're going to look at post-FEC CRC, and I said, and you had retry also in your text. I said add it in the graph too, because all of those post handling, pre-FEC, post-FEC, or pre-CRC FEC, it's something that then you have to see what kind of latency you added. Okay, so latency, it's good, but I also think, and you also have a mention of overhead, because CRC, you're going to add some bytes, right? And then a retry also,
Sorry, I understand, Majid, that we have only 2 minutes. I
Okay.
don't understand the sentence when you say needs to consider. Why the reader of this paper needs to consider that?
Because, okay, so maybe the sentence is not good. I agree. So
if you make this sentence generic and say, hey, any kind of error correction or retry scheme is gonna
error handling, let's say,
error handling is gonna add to normal latency and power or overhead, I'm fine with it.
That's what I meant. That's what I meant.
But when we say, hey, you need to consider, then they
Okay, no, let's rewrite it then. So how should we say?
I think then the best place for it is
Error. So let me go to. Well, actually, let me see.
actually the place is good, that you're in the right place. Over there, we can just say, hey.
So I would say like this. Okay, I don't know why it's error handling, all error handling schemes, in parentheses, CRC, FEC, retry. Will result in some degree of added latency and at least overhead. That's if we want to keep it simple.
How about this? Will result in some degree of overhead in latency and power.
Yeah. some degree of
overhead.
no overhead for me is a category itself. Is how many bytes.
Yeah, but I'm using overhead as just different
Yeah,
meaning.
but overhead that overhead had a meaning, you know, so I can even be very specific. Example, PHY or CRC bytes. That's what I mean by overhead.
I know, but okay, you want to say that?
Yeah, degree of added latency and overhead. Okay, so that's all. And then later you're elaborating yourself, you know, and that, you know, that's how, you know, effectively you're considering it. That, but you're right. We're not saying consider in a sense. So you could feel free to do that. That all I wanted to say
No,
that.
this is good. Then
Yeah.
let's.
Okay. Good. So that's it.
Any other comment, Majid?
No, and then on the presentation, I had a very minor change, but
Which
I
one do
think,
you want to show that to us too?
okay, let me
We have
see.
passed by 1 minute. Guys,
Yeah.
feel free to drop, but
No, actually, it's okay. I think you look at it, and because I'm not part of that presentation, you could see I added a comment, so you could
no,
decide.
just show it to us. I do have time. I can.
Because I have a call on the OCP, the PCIe PHY logical. I have to go on it. That's why I'm a bit sorry. Let me see, where the hell did I put it? Maybe I have it under downloads. Yeah. Yes. And then I can add it to where is that? Okay. I don't know why the share didn't work. That's okay. Sorry about that. Okay, there. Okay. Sorry. That is won't take too much time. Let's see. Share. My share screen disappeared. Okay, there. Okay, so it's very basic changes I suggested. One of them, right. Let me see. Yeah, I think here you see you have in this box PHY CRC. I just added retry also there.
we had retry.
Mm-hmm.
I don't know what happened to it. If you look at the text,
Yeah, maybe it's there.
where did you put retry? Sorry.
In that box, I wanted to put it, but it's not there right now. I don't know why. Oh, because I had downloaded this. And anyways, this is a figure. I cannot change it. I
Correct,
added
but where do you want to add retry?
under PHY CRC retry because your
Yeah, but
latent
retry is not the physical implementation. There is no block that you call it retry. You just retransmit.
in PCIe where they have retry is part of PHY logical. Okay, PHY
I
CRC.
know, but do you see it as a separate block?
Yes,
For
it's
the
actually it has
transmitter
some
retry
logic in
and
there.
receiver retry?
Yeah, they put a buffer, few buffers, and then if it's they go back replay from the parts that so there's a logic that does that. A bit similar. So I mean, it's not important. I don't think it's anyways up there. You already have it, right?
Okay, that's good.
Yeah, because you have BL3. I don't know where BL3 is, but you're not showing it.
BL3, because we said that it's a bit error rate of the full length. With the respect to the retry, what is the targeted?
I see.
Because usually with retry, you target some bit error rate and you say, hey, with my retry mechanism, I will guarantee that you get to 1e to the power of minus 12.
Yeah, but the way I understand this is it works exactly similar to FEC and CRC. You need some logic. Effectively, at least you could have retry at a much higher layer, like in Ethernet TCP, you have it at layer 3, or in PCIe, you have retry in PHY logical. So you could add at multiple layers. That's another thing.
But
So
usually you do that with the targeted bit error rate, correct?
Sure. Yes. You make some assumption and particularly in TCP, you actually aim at a zero error, right? You are 100% reliable. That's layer 3. But in PCIe, retry happens if you couldn't detect and if the error is not, it cannot be corrected, right? And they say that it's very rare, so hence retry latency is not significant, or they prove that it's very small. But some transaction, for example, we did a study where in memory accesses, even small amounts can result in latency of a whole process of AI processing. So it's not, especially if the bit error rate is too high. But I think for the purpose of this presentation, it's okay. Ignore actually that. It's okay. You already have it.
Okay.
All
Thanks.
right. Thanks. Have a good day.
Thank you, everyone.
Bye. Yeah. Bye.